A galaxy that is around 13 billion light-years away has been discovered by the James Webb Space Telescope, which is operated by the National Aeronautics and Space Administration. This galaxy features a striking resemblance to a younger version of the Milky Way, in addition to being one of the first examples of its kind. The Firefly Sparkle galaxy is one that exhibits early indications of being a galaxy similar to the Milky Way. Learn more about the early stages of galaxy formation, which are similar to those of the Milky Way, by watching this video and discovering what the Firefly Sparkle galaxy has to present to us. Welcome back, space enthusiasts, to another mind-blowing episode of Spaceverse, where we unravel the mysteries of the cosmos. Today, we're diving into a groundbreaking discovery made by the James Webb Space Telescope. Discover the secrets it holds about the birth of galaxies and the evolution of our universe. Don't forget to like, subscribe, and hit that notification bell to stay updated on all things space. Let's get started. James Webb was able to identify the extremely faint and far-away Firefly Sparkle galaxy using a mechanism known as gravitational lensing. This is a process in which the gravity of a huge object, such as a cluster of galaxies, bends and magnifies the light of a smaller object, such as a galaxy in the background. As a result of this, Webb is able to observe galaxies that would be inaccessible to the human eye, due to the fact that it is located behind a massive cluster of galaxies, which acts as a natural telescope. The light from the Firefly Sparkle galaxy is magnified by a factor of 10. The fact that Webb was able to identify it at a redshift of z equal to 8.3 means that its light left a galaxy at a time when the universe was only around 600 million years old. Within the context of the history of the universe, stars and galaxies were just starting to take shape at this period. The measurements demonstrate that the galaxy has a diameter of around 2,050 parsecs, which is equivalent to a length of approximately 6,500 light-years and a mass of approximately 10 billion solar masses. It has the appearance of a disk due to the presence of a core bulge and two massive spiral arms. In addition to this, it is actively manufacturing new stars, as seen by the blue pigmentation of its surface. A network of star clusters, which are groups of stars that are gravitationally bound and have a common origin, are evidence of how galaxies form. The Firefly Sparkle galaxy features a network of these clusters, which is what distinguishes it from other galaxies. As a result of their capacity to coalesce into larger structures, such as the bulge and globular clusters that make up the Milky Way, they play an essential role in the process of galaxy creation and evolution. Within this galaxy, there are approximately 20 star clusters, and the masses of these clusters range anywhere from 10 million to 100 million solar masses. The formation of these star clusters occurred nowhere more than 10 to 100 million years ago, making them fairly young. The luminosities of these objects are anywhere from 10 million to 100 million times higher than that of the Sun, which means that they are also exceedingly luminous. They are responsible for around 80% of the light that is emitted by the galaxy. In the same way as the Milky Way and other galactic centers are surrounded by circular clusters of old stars, this phenomenon can also be found in the local universe. There is a widespread belief that globular clusters represent remnants of an earlier, more chaotic and densely packed universe, when galaxies were still in the process of developing into their current forms. It is possible to have a better understanding of the formation and evolution of these globular clusters with the assistance of this galaxy that was discovered not too long ago. Numerous characteristics, such as mass distribution, age distribution, and the history of star formation, are only few of the many that are disclosed by them. Some star clusters are younger, less active, and larger than others. These characteristics distinguish them from other star clusters. It is clear from this that the star clusters do not have a harmonious relationship with one another and most likely originate from different locations across the universe. Furthermore, this provides evidence that the Firefly Sparkle galaxy is currently undergoing a galaxy formation process that is both active and complicated, because it is the largest and brightest of its kind. The star cluster known as the Firefly Sparkle galaxy, which is located in the core of the galaxy, stands out. To put it into perspective, its mass is around 100 million solar masses, and its brightness is approximately 100 million times that of the Sun. Due to the fact that it is just about 10 million years old, it is quite young. Due to the fact that it is so bright, Webb was able to record its spectra, which are light fingerprints that reveal the chemical composition, temperature, and velocity of the source. The spectra of the core star cluster have revealed significant traits that shed light on the conditions that led to the formation of the cluster. For instance, it possesses qualities such as high temperatures, poor metallicity, and an initial mass function that is top-heavy. Some of these properties are listed below. Due to the high temperatures, the core star cluster has an average temperature that is above 40,000 Kelvin, which is equivalent to 72,000 degrees Fahrenheit. This makes the core star cluster extremely hot, considering that the average temperature of the Sun's surface is approximately 10,000 degrees Fahrenheit, 6,000 Kelvin. This is a substantially higher temperature. The presence of bright stars with masses that are larger than 10 times equivalent to that of the Sun is indicated by the high temperatures of this object. In addition to being highly rare, these stars are also extremely radioactive and possess a high level of energy. On the other hand, a core star cluster that has a low metallicity would have an exceedingly low quantity of carbon, oxygen, and iron, in addition to other heavier elements besides hydrogen and helium. During the process of stellar nuclear fusion and the supernova explosions of big stars, these elements, which are collectively referred to as metals, are produced according to astronomical principles. This indicates that the center star cluster is formed from gas that was not enriched by stars in earlier generations, lending credence to the notion that it is relatively primordial. Another result of this is that the core star cluster displays characteristics that are similar to those of the first stars to emerge from the universe, which are also referred to as population 3 stars. Last but not least, the center star cluster has a higher number of massive stars than what would be predicted from a normal distribution. This is because the initial mass function of the cluster is top-heavy. It is a mathematical function that describes the number of stars of various masses that are formed in a particular place. This function is known as the initial mass function. The bulk of star-forming regions in the local universe adhere to a normal initial mass function, which means that low-mass stars outnumber high-mass stars. This is the case because low-mass stars are more abundant. A top-heavy initial mass function is indicated by the fact that the center star cluster has a greater number of high-mass stars than low-mass stars by a significant margin. This leads one to believe that the gas was compressed and then split into enormous clumps in an environment that was turbulent and dense. This is the most likely explanation for the formation of this cluster. It is a remarkable element of the Firefly Sparkle galaxy that it has a companion galaxy that is located at a predicted distance of around 2 kiloparsecs, which is equivalent to 6,500 light-years. And it has the same redshift as the Firefly galaxy. This dwarf galaxy, which has a mass of approximately 1 billion solar masses and a diameter of approximately 1,600 light-years, is less bright and smaller than the main galaxy. Approximately half a kiloparsec is the size of this object. The red color and spherical shape of this object give the impression that it is less active in star creation. It is possible that the interesting partner galaxy is connected to the star clusters that are already present in the Firefly Sparkle galaxy, which would make it much more intriguing. It is possible that the companion galaxy is interacting with the Firefly galaxy or merging with it. This could explain why the star clusters formed, or at the very least expedited the process of star formation. This is because as galaxies contact or merge, gas can shrink into new stars and star clusters, which means that the gas becomes denser and more unstable. This is the reason why this phenomenon occurs. Because the history and origin of the star clusters are distinct from those of the Firefly Sparkle galaxy, it is possible that the star clusters have a wide range of characteristics. It is possible that this neighboring galaxy is a dwarf galaxy that was engulfed by the gravity of the parent galaxy and took some gas and stars with it. As a consequence of this, it is possible that some of the star clusters were heavier and more metallic than others. It is possible that the probable alternative to the fate of the Firefly Sparkle galaxy will have an effect on the future evolution of the particular system. It is possible that at some point in the future, together with the Firefly galaxy, it will come together to form a galaxy that is even larger and more massive. In addition to this, there is the possibility that this will cause a metal and energy feedback into the cosmic medium, which might ultimately result in an explosion of star formation. There is also the possibility that this galaxy will break off from the gravitational pull of the primary galaxy, resulting in the formation of a secondary galaxy that is of far lower mass. Because of this, it is possible that the feedback of the system and the creation of stars will both be reduced. We are in possession of a one-of-a-kind and priceless opportunity to investigate the role that galaxy mergers played in the early formation of the universe by means of the companion galaxy, and the potential interaction, which is extremely important and highly relevant. The interactions that they have with components that are smaller and more straightforward are the source of the diversity and complexity that galaxies exhibit, which they shed light on. A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.